everybody. Welcome to another episode of Analytics Mindset. This time we're going to go back to Python and functional programming in general. I will cover the bare basics of functional programming in this video. You may want to go back to my absolute programming basics video that will be somewhere over here as I talk more about the basics of Python there and how you can start with programming in general. For this video, we will start with functions and their uses. Everything related to functional programming, a very high level. I won't go into technical definitions. I will leave resources in the description in case you want to go a little bit more into detail. But first, I will start with some variables, and this is a package that we're going to need called inspect. We are going to import. That's the only package that we're going to use it. And in contrast with a lot of my videos, I will start with some variables. I could have started instead with usual data frames or columns, but I want to start from the basics. Let's go back a little bit, focus not that much in data analysis and how to get all these metrics, but instead, how do you pass stuff into a function? Why do we need functions and all that stuff? And for that, these variables here will be more than enough. As you can see, I have a Boolean variable that is going to be default true, a number variable that's going to be 255, yes, because it's a number, I just need a number, and a string variable that says this is a string. Now, let's put ourselves in a practical scenario. We are a Python developer, or software developer, as you prefer, and we want a custom formula that's going to take the num variable and then give us an inventory calculation. We are going to call it holding inventory. In case you're not familiar with holding inventory, anytime something comes to a facility, you need to tie some part of that money for holding that inventory, because storing things, as you can imagine, costs money. Again, if you're not familiar with it, it's fine, but imagine your local Walmart or your local grocery store. When they hold milk, they hold fresh produce, etc. If a carton of milk is there for 15 days, let's say, that would be pretty long for a carton of milk, and it might spoil. That's another expense. But let's say 15 days between it's received and between you get it out of it. The grocery store will incur a cost because the inventory, what you could not sell there, it's time, money that you could have used a capacity for something else. That's the basic concept there. Again, it's fine if you don't understand it. Just understand that there is a cost for storing stuff, and we're going to use a very simplified version of that formula for this scenario. It could be any other formula if you wanted to. There is more than enough mathematical formulas out there to use. I just prefer to use this one because it's rather straightforward and easy to explain. We are going to call it holding inventory, hold int, and we're going to calculate it as this. We're going to call we're going to have the number variable that we're going to assume is our cost, and then we're gonna add a dollar amount. In this case, this translates to 20 cents. So we're saying per unit times 20 cents times 30. This is gonna be the number of days. So this is you can think about this of the cost per day per item. You need to multiply that by the cost per item, and then you multiply that by the number of days that we're going to simplify it as 30. Most months have 30 days. We're just going to keep it as 30. That's the monthly, how we will calculate the monthly holding inventory for this fictitious item. And you can see a more technical explanation here. This is just out of my my head. It's not a formal holding inventory formula. Usually those are way more complicated, but it gives you a very good example of it. You may be asking how this relates to functional programming. I can just do the formula, execute it, and I will have my value that, as you can see here, it calculated correctly, $1,530. That's my monthly expense for this given item. And we can print it here. But functions come into place when, let's say, we want to get multiple of them. So we're gonna have 5 inventory costs that I'm going to declare here. As you can see, It goes all the way from 3, 43, 60, 120, and 140. The original was 255. We're going to have in total 5 variables. So let me correct this. We have 5 variables here. And there is a lot of ways we could do these calculations. One of them that you might be thinking, if you need some more time, stop the video and just think about it for 1 second. But if you're back, we're going to go here. And it should be as easy as doing this, right? I can just execute each of them. Now I have the cost of 1, the cost of 2, the cost of 3, the cost of 4, and the cost of 5. Now, notice here that one of the main issues in this approach is first, I am rewriting the holding inventory formula. Over and over again, the variable is being changed. First, I don't have the other values. I'm stuck with 140, the last one. If I executed this all at once, and you may be telling me, wait, I can just name it different things. I could be like hold inventory 1, hold inventory 2, 3, etc. until 5. You could do that. It is very tedious though. The main advantage of Python and other programming languages is that you can do things like this in a way more efficient way that also allows you to recycle your code over and over again. And that's going to be a very important part of functional programming compared to procedural programming that we have already seen to some degree. We could put them into a list. Let's put all of them into a list, and we already went through iterations and loops. I will leave a link here in case you haven't seen that video. And we can loop through each of the values. So that is going to give me all the way, or that's going to print me the 5 values. I at least get the 5 values there, as you can see. And I have my list. That's better. I can do a lot of stuff with this. I could put more and more code here in the loop and do stuff in the loop inside there. But let's say that we want to add even more code instead. You can add code in the loop. I could say like make this an integer, for example, or print me a more descriptive message than just returning me the variable. Notice how here the precision makes a 4 all the way here. I don't want that, etc. However, I can just call a function instead. So this is the syntax for functions. Going really briefly over them, define, you are defining a formula. That's a reserved word for that. Inventory formula is going to be the name of this function. And this, as you can see here, it's something that I'm passing inside it that I will go into more detail later, but just think about it as something you're passing inside the formula. I'm going to do the calculation that I told you about before. So I'm taking the unit cost, multiply it by 0.2, and then multiply it by 30, and then I'm going to print that. And you may ask me why it didn't return me anything. As you can see, there is nothing here. It's because I declare this to execute this code inside, but these are just instructions. You may think about it as a recipe. That's a very good example of it. I am holding some instructions later on so I can call the recipe instead of calling the whole code at the same time. That is what you will do here if you were just saying, do this over and over again. You are just telling Python, execute me this code. In this case, you are telling Python, execute me this recipe that has this code inside it. And you can see here, I can just do it here. And it's a simple syntax. Instead of calling the whole thing, instead of putting inventory, that is our first variable, 0.2 and 30, I have wrapped that into a formula, inventory formula, and I just call int here, that it is the value here. We just call int is value inside the list for each of these inventory list values here. Now, it is the same. These two are exactly the same. But again, just notice how this is more straightforward because you just call the formula. And you might be asking, well, I can do the same here and I can see what's inside. Yeah, but you can add more code here and you will just call this. You don't need to call the whole thing over again. You can execute it multiple times too. Let's say you want to import formula with another value. You can do that. Well, here we are doing it multiple times here because it's executing that formula for every single one of these. Now, notice how in the formula, we execute it as inventory unit cost. And here it's int. This is outside of the scope of this video, but as a quick notice, that's kind of the deal with arguments and parameters. You are passing something into the formula that then replaces the placeholder. This is the placeholder here. It is just acting as a placeholder for whatever variable that you're maybe putting here. I could have named this whatever I wanted, as long as what's inside the variable here in unit cost was also called that. And it will give me the same result because inventory here, it's just you're replacing this over here. And actually, I will just go ahead and do that to show you how that would be. So let's not call it inventory cost. We're just calling it int. Let's make sure that it's not a reserved word. We're going to call it int because why not? And we replace that here. And then we're going to execute this. So the function has been overridden to the new one. And now we're going to do exactly the same. So we're going to execute this again. Exactly the same. So don't get confused by being called differently. I could have called it exactly the same. It is just a placeholder for when you pass stuff over it. With that being said, again, pretty simple definition, def, then whatever code you want to put inside. The colon here indicates you that you need to do exactly the same thing as we have done with the if statements, for example. The chunk of code needs to be inside the indentation because that's how Python differentiates between code inside this function, code outside this function, and in the main script. With that, we're going to pass into the next. Let's define the function again. We're going to do some more stuff here. See how here I have exactly the same formula, but I am adding the bool bar as an argument here. I'm passing that inside too. I'm saying if bool bar is true, that I hope it is, I declare it as true, then first do the calculation, then convert that into an integer for me, and then print for me your inventory this month for the inventory unit cost is the holding inventory. And else, if the bool bar is false, there was an error. I just want to do that. So I'm going to define this here as inventory formula. And then I'm going to just call it with the list that we had before. You can see there, I just call exactly the same formula, the same function that I had before, inventory formula, but it gave me a different output. Before, it just spit me out the values without any context. Here, it is actually telling me an actual message that is way more useful. I can now say, okay, for 3 units, this is my cost. For 43 is this, for 60 is this, for 120 is this, and for 140 is this. I have something more useful to me, and probably also way more transparent to the user, because the user just doesn't need to get you obscure numbers without any context, but it actually knows what you're referring to, assuming that they know their domain expertise. Going to the next one, we can pass as many arguments as we want. I'm not gonna go into detail here, but there is args function that you can pass in, make your functions way more complicated than that. But let's do a scenario to say how this could be useful. Is like, let's assume that somebody in the accounting department needs a formula for X periods, where X is going to divide the month. So let's say bi-weekly, more or less, you're going to divide the month to 2 different ones, 3 every 10 days, 4 every week, more or less. We're going to say that X is an integer between 1 and 3, and it is specified by the user. I'm just going to make it 2 right now. And then we are going to modify our function to make it a little bit more flexible. So I'm passing X here, as you can see. And then I am doing here is give me the holding inventory that's going to be the integer of what I had before over X. You're going to divide that by X times. And then you're going to print this message that says your inventory for each X period for per month for this is this. I'm going to define this. And now I'm going to do the same thing here. Notice how 2 is all the period per month because I did it as that. I said X is equal to 2, and you're getting different values for each of them. You are dividing that cost over 2 because it was 840 before and it was 420 before. You could do this in the loop if you wanted to. But again, if you want to do more stuff in the loop, there is a lot of stuff you can do in loops, as we have seen before. It will just explode in complexity, and you may just be stuck onto there's so much code here, and I don't know what it does. Functions allow you to put all of these somewhere separately, and you can just call it over and over again, as long as it is before the where you want to actually do it. But again, that's just a preference. Some people prefer to put all this stuff, including myself. I am not really, practically speaking, a good functional programmer. I prefer to speed it, all of it in my code and call it more in the procedural way. But it is an advantage. You can do it, and there is no correct way to code. Sometimes functional programming will be better for some scenarios, sometimes procedural. You can combine procedural and functional. You can put multiple functions inside a procedural list, and you can put multiple procedures inside a function. At the end of the day, Python is very flexible in that regard, mostly because it's an object-oriented programming language too. But you can do a lot of stuff knowing both approaches here. Now we can build on these functions as much as we want. We already did it. We have used functions already. We have used sum, print, etc. All those functions that are pre-built. We have used more complex ones for linear regression, logistic regression, random forest. All of those ones are functions that sklearn has behind the scenes. All the math that the model needs to do is stored there. It is exactly the same as these ones. These ones are just way, way, way simpler. But just think about it this way. Anytime you call something in Python that has that is a function, there is a lot of code behind it that allows you to do what the code wants. Again, sum is a pretty good example. It adds stuff, etc. So functions can also be useful for putting other stuff over it. We did this for a holding inventory calculation, but let's look into something different. Repeat string. The repeat string formula has two arguments here. We have the string and the number of times. It's going to have a for loop inside it. So I'm saying for I in range, number of times, how many times I have, I'm going to print that string and print below the string, this is iteration I plus 1. Why I plus 1? Because Python starts from 0, and I want it to be 1, 2, 3. Because if not, it will be 0, 1, 2. And you will see what I mean soon. I'm going to just take this, and remember that number of times is not a variable right now. Number of times is going to be whatever I pass it to it. My function is there now. And now I'm going to do this. I'm passing to this function the string variable that is, this is a string, we did it all the way here, and inventory 1. As you can see, it made it 3 times because it's 3, and it executed as we expected it. This is a string, this is iteration 1, etc., 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 until you complete all of them. Now, before going into a little bit more detail, let's just do something. We are going to take the bool bar and make it false. So we are writing the bool bar into false. And then we're just going to take this inventory formula again and execute it. There was an error. Why? Because I said else print there was an error if bool bar is not equal to 2. again, as you can see, it is fairly straightforward. You could do exactly the same in your main code, but this helps you to encapsulate it here and make it into a smaller chunk that then you can refer to. And the best thing, instead of repeating yourself, let's say we need to call this inventory formula with different lists. You don't need to modify it every single time you call it. You modify it inside the function. Whatever you change it, as we have done it before, it will modify it everywhere else once you declare it again. And that's more probably one of the biggest arguments for functional programming. You can save yourself a lot of times by just fixing it in one place and not going to every single time you do the same procedure. And anytime you do an operation, it can become a function. Again, it's just some people prefer to do it all functions, some don't. It's really personal preference. You will never get an answer to which approach is better. It depends on the field that you are to and the programming language. If you're doing some other programming languages, you will have different opinions as well. But we have called that and we have repeated that string. Now we want to get the result. So we know in the inventory formula here, we got different numbers. I want to get those numbers. I got them print, but I don't have it anywhere in my Variable Explorer, as you can see here. This is actually rather easy to do. There is a word called return that you can use here. It's a reserved word that you can use for this. So I'm going to change my formula again. As you can see, inventory formula now has exactly the same that we have done before, but it's going to return hold int. This is the difference here. Instead of just printing stuff here, I'm also going to hold it here for return. Now, what happens if we call it? There was an error. Just take 1 second to think why there was this an error. It's a good practice, and I prefer to make this a little bit more interactive than before. Pause the video, think for a second why there is an error. I hope you're back. The reason is I declared boolbar as false before, so I need to make it true again. And now I can print. I'm going to get my inventory formula here, the output that I defined, and I'm also gonna get this out, 129. Now it's not stored anywhere because I didn't store it anywhere, but notice how I have this now, while before when I was doing it, I didn't get it at all. And I can capture this. How do I capture this? The easiest way that we have ever done. I just need to assign it to a variable. So I'm going to assign it to hold inventory result. As you can see, the out is not there, but now I have 129 here inside. This is how you get stuff out of functions. There is a lot of other things that you can do. But one of the easiest ways when you are with functional programming and functions is just put in return. Return will give you that value back, and then you can use it for whatever you want. You can, as you can think about it, every time you execute the script, you could take these values, return them in the main script, you could pass them to another function if you want to. You could do a lot of transformations. Maybe you got to write them to a CSV. That's something that we may or may not explore later, how you read and write documents, how you automate stuff for Windows. There is a lot of possibilities you can do with this, and it will help a lot with automation specifically. We can print it too. 129. Now, finally, let's do one more thing. I want to get the code behind. So let's say that you have no way to see the code for whatever reason. It is hidden, so you don't have access to this. You know that the formula is there. You just don't know that it's there. And there is ways to do that I'm not going to go into this video. But inspect can be using for that. I can do like the code for inventory formula function is this, and I'm going to do also the code for repeat string. It's this. I'm going to print this. you can see here, it gives me back all the code that I had in inventory formula, the last one that I declared here. And I can do the same for repeat string. And I get my code. So inspect is an easy way to get the code behind it if you need to do stuff there or if you need to modify it. Again, there is a lot of ways to do stuff in programming languages. Functional programming is one of them. It saves you time though, and allows you to do something that you will do multiple times. You just declare it once. When looping is not possible, that's a very big advantage there. There is also a lot of things that you can only do with functions. You could do those functions that, in this case, are custom functions that we have declared. They only live in the script. Once I close the script, they don't exist anywhere. You can actually do even fancier stuff than this. You can put those functions in your own script somewhere in your computer and then call that script, call that function, and you could declare a package. That's one of the most basic ways of creating a package on Python. I'm not gonna go that much into package creation, but if you're interested in that, there is a lot of resources out there. The Python community is huge. There is information everywhere, and if you ever want to go that route, that's an amazing route that a lot of people take and contributes a lot because people create the functions, they create the packages, and guess what? They share them. That's how we have access to things like sklearn, NumPy, etc. Smaller projects exist. I'm just giving the big headers, but that's one of the marvels of open code or open source code. Everybody can share their packages, and you can just install the packages. And with that, I will close the video with saying again, thank you for watching this video. Any comments, any support that you may want to give me, I fully will appreciate it. And I hope you have a good day. Thank you.